rotating galaxy. The laws, the rules by which plasma operates give us a very one-to-one correspondence with that kind of rotation, that galaxy rotation. A good friend of mine who was one of the directors of the Los Alamos National Laboratory here in the States did I think it was his PhD thesis, or certainly shortly thereafter, did a simulation on a supercomputer of a bunch of plasma. He put in the rules of how plasma operates, that is Maxwell's equations and the Lorentz equation, and just duplicated the way that swarm of plasma. You could see it evolving into a galaxy, and it ended up rotating in exactly the same way with exactly the same profile as real galaxies do in space.
Oh.
And Newton's laws will not enable us to explain that kind of rotation, but Lorentz's law does.
Donald, sorry to interrupt, but that's very interesting, because I've heard this theory regarding, dark matter, that they came up to this theory basically because the computer models that they were running on the universe, they kept, the model kept falling apart in these computers, and they have to basically add a whole lot of matter to kind of keep the structure together. Isn't that right? Have you studied this?
Well, there are two different things. There's dark matter or missing matter, and then there's dark energy, and they're sort of similar. In my mind, they're all fairy dust. That is, see if I can remember my acronym. Fairy dust is something like frequently invoked inventions that are I can't remember the acronym, but they're conjured up to defend untenable scientific theories. When your theory doesn't work out, well, you can invent an invisible, unmeasurable thing that just has to be there because we know that our theory is right. And we measure this expansion of the universe. That's where the dark energy came from, is because the Einstein relativity will not explain the expansion at the rate at which it is perceived to be expanding. Whereas the dark matter or missing matter was to explain this thing that I'm talking about, the idea that the galaxies don't rotate as they should, quote unquote, if Newton's law is the only thing that's at work out there.
So,
one of the things I should mention that I think I wrote to you about is that I mentioned Dr. Tony Peratt, who did this simulation of galaxies. His thesis advisor was I was going to say very famous, but he should be very famous, Swedish electrical engineer. His name is Hannes Alfvén. And I don't know whether the normal walking around Swede in Stockholm, if you mentioned Alfvén's name, whether he'd say, "Oh yes, of course," or whether he'd say, "Who's he? I never heard of him."
I guess the latter is correct.
Well, he in my mind, he is a giant. He won the Nobel Prize in Physics in 1970. He is really the father of plasma cosmology. Wrote several books. One called, to my mind, one of the best is called Cosmic Plasma. He's just responsible for the basis of all of this material that's in my book. Now, the idea of the electric sky, after Alfvén's death, of course, his work is being carried on in various places, not in any department of astronomy, I may say.
Oh, okay.
It's funny. Alfvén was a member of some of the world's biggest astronomy societies, and whenever he would walk into a conference, all of a sudden a hush would just fall over the crowd. All of a sudden, here's this Nobel Prize winner who is diametrically opposed to many of the ideas of, this dark matter, and there can't be any electricity in space because it would mutually repel. And it was interesting. Tony Peratt, his student, has told me, sitting here in my house with a drink, he'd say, when Alfvén would walk in, it was just like all of a sudden the police had crashed a party. And there was absolute respect on the part of astronomers for Alfvén. But they somehow, they just managed to ignore just about everything he said. And after his death, and that's the reason I asked you, how much do you think people would recognize his name? It's a real tragedy that his work has sort of been allowed to lapse.
We definitely need to give me his full name again.
It's Hannes, Hannes.
Yeah.
And you can tell me the pronunciation. I have a very good friend whose name is Siegfried Ingvason, who I said, Siegfried, how do you pronounce this fellow's last name? It's A-L-F-V-E accent N. And Siegfried said, well, that's Alfvén.
Alfvén, yeah.
Yeah, and well, then I've heard another fellow on a video program call him Alfvén. So I don't know what the right pronunciation is. Henrik, I leave it up to you to get the right one.
We'll say Hannes Alfvén. That's probably correct, yeah. Okay, so, that's interesting because it seems to be a lot of these people within this field, because another one that is maybe not that lost in regards to his name, but almost forgotten, I guess. It's Immanuel Velikovsky, right? How does his kind of research?
Yes and no. Velikovsky was not an electrical engineer or an electrical scientist, or even I wouldn't say a scientist in the hard sciences in any way. He was more of a historian, a mythologist. He was very enmeshed in Judaic history, and he. I'm just giving you my opinion.
Yeah, sure, yeah.
He was very, very, very badly treated when he wrote his books. The big one, Worlds in
Collision.
There was Earth in Upheaval. There were several others, I guess.
Yeah.
In my opinion, at least in the opinion of Wal Thornhill, whose name you mentioned, and Dave Talbot, Eduardo Cardona, and a bunch of the other of our group, he was totally poorly treated, but most of what he said, unfortunately, was wrong. But one of the things that where he wasn't wrong, in our opinion at least, is that he was the first, I guess modern, if you want to talk about 1950 or so as being modern, person to say that the Earth has gone through some severe cataclysms, within man's historical memory.
Yeah, sure.
And that is within the last 10,000 years, something like that.
Yeah.
And it's becoming more and more obvious and more accepted that yes, Earth has had a very violent history from time to time. There's been 5, as you probably know, major extinctions.
Yeah.
The one that people talk about is the extinction of the dinosaurs, and there's this theory of who is it, Alvarez, that said that there was a comet or an asteroid or something hit the Earth, and there was this total worldwide catastrophe, and what killed off the dinosaurs.
Yeah.
There's a great controversy about, is this true, or why did the dinosaurs die? Of course, then I ask you, and why did it happen 4 times before that? It's been going on, and Velikovsky did get that right, I think.
Yeah.
As far as his ideas about, the planet Venus being born out of the red spot in Jupiter and that sort of thing, people, I think, pretty much have said that no, that's not right.
All right, yeah.
But he, as I say, he was not really a scientist. He wasn't an electrical engineer. Alfvén, by the way, was an electrical engineer, worked for one of the Swedish power companies. And how he got into this was you know, Sweden has some of the highest voltage transmission lines in the world, I guess.
Oh, okay. Okay. I didn't know that ours were so high, but...
Oh, yeah. I guess, as I understand it, Sweden was primary in high voltage DC transmission.
Mm-hmm.
If you try to transmit power from the hydroelectric stations in the north down to Stockholm and Göteborg and places like that,
mm-hmm.
You need to be very efficient in how you do it. And so they went to high voltage.
Mm-hmm.
As a result, they had all sorts of arcs and sparks and explosions and switches that didn't work. And Alfvén became very interested in this,
yeah.
and realized that these phenomenon that were so ruinous to the power transmission were really plasma phenomena. I should say phenomena. And he studied them and then began to see a sort of an application of that work in high power transmission to what astronomers were beginning to see in the sky. And once you see these patterns are the same, you can begin to make progress. Somebody once said the best scientist is the fellow who's able to know something about two different areas of science, and when he sees a problem in one area, realizes it's kind of analogous to a problem in the other area that's already been solved, he can say, "Ha, I know your answer." And that's pretty much what Alfvén did.
Ah, okay, very very interesting. And by the way, just one thing that came to mind here: does this have anything to do with stuff like ball lightning and these kinds of things?
Oh, very much so. Yeah, ball lightning used to be thought of as being how should I say it, a kooky thing that didn't really exist, only believed in by people who were either very strange mentally or who had too much to drink. You know? And that's not at all the case. The Physics Society here in the U.S. and I think probably around the world is beginning to take a very, very close look at ball lightning, and they recognize that it is a very, very real phenomenon, and it is plasma, absolutely. And Alfvén once said that you can analyze plasma by all sorts of tensor equations and differential equations and integrals, and somehow the plasma doesn't either it doesn't understand the mathematics, or it's too clever and naughty a child to obey it. So plasma acts in very, very strange ways, and ball lightning is an example of that.
I mean, I saw a video, I think it was last night, with some guy who had filmed this huge thunderstorm coming in, and besides the clouds, kind of external to the clouds, were these 2 or 3 different balls that kind of popped up out of nowhere and traveled kind of just around. It looked like a traditional, I guess, UFO sighting, basically.
Exactly. In fact, I suspect that many UFO sightings are not all necessarily, but that some certainly are ball lightning. And there's the phrase, I don't know if it's in Swedish as well as in English, but there's a phrase called a bolt from the blue. It refers to something happening unexpectedly. Sure. What it means is a lightning bolt coming from blue sky.
Yeah.
And you say, well, how can lightning come from a blue sky? Well, it can, and it has recorded that you don't necessarily need clouds, although that's where most of the lightning comes from. Some, it just comes boom out of the sky from, I don't know, from the Van Allen belts or from where, but there's certainly a charge imbalance, and you can get bolts from the blue.
So these things are something that defies the laws of physics, then, I guess.
Well, not really. It's just that it may well be that we don't understand exactly all of the physics that is going on. We understand pretty much how plasma works in the laboratory and experiments.